Hello, Precalculus student. This video is for chapter 6.1, graph of sine and cosine functions. So in this chapter, we're learning to graph sine and cosine functions. You might say, Ms. Chen, we already know how to graph it. It's in the unit circle. No, the unit circle is not a graph. Unit circle is a graph of a circle where the point of intersection represents the sine and cosine function values. So the unit circle is a graph that had the unit circle and it contains it's like a machine that produce sine and cosine by reading the points, right? So the sine and cosine function is actually a function where the input is an angle. So you would see 0, pi over 6. I primarily would be using radian notation instead of degree because the exact definition of the sine and cosine function is actually by default is radian. So it will be all these degree. And if you use the unit circle to read off the value, you'll see that sine pi over 6 is 1/2, sine pi over 4 is root 2 over 2, right? So, and then, so this, if you look at this is the input and this is the output. In this case, x is actually the theta value. You can use it. You can also replace the variable as t. In the unit circle, we write the input or the angle as t. So instead of using t, we use x. But this is the different x as compared to the unit circle x. So this would be a table of a function. X is the input, sine x is the output. And you will see that the values changes, right? So when it is in pi over 2, it becomes 1. We can plot this value and you find that it is actually a smooth curve. And the curve is periodic. So I'm going to show you a program that Wolfram Alpha had, where it is like a program that you can plot the angles, or the angle is the x-axis, the y-axis is sine theta, sine x, and you can see how it goes. So right now we have angle, the angle value is 0. So if I move this around, you can see that the angles is increasing, and the y value is actually the vertical length of this point of intersection on the unit circle. You can see that it is plotting it. Okay, so if I go to x equal to pi over 2, so this is when the angle is pi over 2 in the unit circle, then y would be 1, right? So there's a point 0 and then a 1. And if I continue to move so that the angle is pi, so see this in the unit circle, this is pi. The y value is 0. So you can say pi comma 0 is part of the sine curve. And then I can go on. You will see that that's actually the pi curve from 0 to 2 pi. Now, in this particular illustration program, it only plot from 0 to 2 pi. But presumably, I could move these angles back and forth, move to negative. So it will plot a graph like this, and also move to 4 pi, 6 pi, you would see this goes on the same. Why? Because when I go to go past 2 pi, I'll go back to the original. So all in all, you can see that the sine function, the basic cycle is from 0 to 2 pi because that's the 4 part in the unit circle. And then it would actually presumably goes on forever. So on the negative side also, this is the graph of the sine function. Similarly, we can also write a table of t and cosine t from the unit circle. And if we replace t by x, then I have x cosine x, also a similar table of value. But because we're reading off cosine, which is the x value of the unit circle, you would see a different table. So if you compare the two tables, here. At pi over 6, x is 3 over 2, y is 1/2. You can see that 1/2 shows up in the sine table. But with 3 over 2 shows up in the cosine table, the input is pi over 6. And so let's look at the other project. This one is cosine, right? So if I start from 0 again, so right now I have angle 0. What is the y value? Y value is 1. So you can see that the graph actually starts from the beginning here. And if I gradually move to pi over 2, it would be 0 because this point is 0, 1. The x value is 0. And then if I continue to move to pi, it would just continue to drop, right? Drop to -1. So the cosine graph is like that. It start off from 1, go to 0, and then go down to -1, and then at pi to 3 pi over 2, go back to 0, and at 2 pi, it go back to 1. So you can think of it as like a V shape, but kind of a curved V shape, where on this side, the curve is curving down, and this is curving up. Okay, so this is the basic cosine function on one cycle. If I in this particular program, they don't allow me to move to 4 pi and 6 pi, but you can visualize that if I move this again, then the graph will plot from 1 and then down again. So both sine and cosine are periodic functions. You can see I graph it in the notes here. So start from 1 to 0, and then to -1, back to 0 to 1. And then if I move on, it would go on forever. On the other side, it goes on forever. You can see comparing the sine and cosine function, they're both similar shape, right? They go up and down, but for the sine function, you go from the x-intercept to maximum, to another x-intercept to minimum, to another x-intercept. There are 3 intercepts in one basic cycle, and then the cycle repeat. Whereas in cosine, you start from maximum to intercept to minimum, and then go back to intercept to maximum. You start and end at the maximum. Okay, so these are the differences. So what are some features? So we're comparing the features of the two functions. Both graphs are periodic, meaning they repeat. They goes on forever. That fluctuate between 1 and -1. The similar thing is the graph repeat after 2 pi. So we call this the period. The period of one cycle is 2 pi, meaning if I have sine x and I add 2 pi, it's the same y value as sine x. If I have cosine x plus 2 pi, it would be the same as cosine x. And if you also look at the graph, the cosine function has even symmetry because the left and right are the same, right? If you look at the left and the right of the y-axis, it's symmetrical. So it's an even function. The sine function has odd symmetry, meaning if you turn this graph upside down, rotate 180 degree, it's symmetrical about the origin. So cosine function is an even function, sine function is an odd function, namely sine negative x is equal to negative sine x, cosine negative x is equal to cosine x. We talk about those in chapter 5 already. What about another similarity is the domain and range. If you look at these two functions, their range is only fluctuate between 0 and 1. You never see the function go down to infinity or flatten, right? Flatten as a horizontal asymptote. There's no horizontal asymptote, and there's no end behavior because it doesn't go to infinity. It just go up and down periodically. So the range is from from -1 to 1. Domain would be negative infinity to infinity because presumably the angle can go on forever. So let's look at introduce some terms to describe these two functions. And I want to summarize the sine and cosine function like this. So this is kind of the new toolkit function. Remember, we have toolkit function, y equal to x, y equal to x squared, y equal to 1 over x. And after we learn exponent and log, we have two more. Now we have two more. So the basic sine function would be one loop, 0, 1, 0, -1, 0. So that's kind of like the toolkit function. We from 0 to 2 pi, so this is one cycle. So it should go on forever, but a representative one would be one cycle of sine. And one cycle of cosine, you can graph it like this. So do the 2 pi here, and you will say this is the middle quarter, like that. So the cosine, you have to do the quarter. Otherwise, you would look like a big V shape. So curve down, curve back up, curve down, up. That's the cosine function. So I think I'm going to talk about the amplitude and period, like the new the transformation of sine and cosine function in the next video. So this is the basic sine and cosine function. Okay, basic one. Maybe I think I will talk about the 5 key point of this the sine function. What are the if I am to write this 5 key point of sine function? What are the 5 key point? 5 key points would be this point, this point, this point, this point, this point. So let's actually record it. Maybe I'll record it here. 5 key points. Maybe I'll erase it over here and write on the other side. Because if you write, you click the 5 key point, you can actually graph it. In order to graph it, we should have like the from 0 to 2 pi cut into four quarters. Okay, just like in the unit circle, you have 4 quarters. So the first one is 0, 0 for sine, right? For sine, the first is 0, 0, and then you go to pi over 2 and 1, right? X is pi over 2, y is 1. And then you go to pi, it becomes back to 0. And then you go to 3 pi over 2, x is 3 pi over 2. Y go to, or sine go to -1. And then when x is 2 pi, sine is 0. So this is the 5 key points. And for cosine function, let's do the 5 key point. 5 key points. So when we graph some other transformation of sine and cosine functions, we also need to list the 5 key points of cosine function. So, okay, we just say the 5 key points. The first is what? So let's mark this. So you can see that I divide this into from 0 to 2 pi into the middle, which is pi, and then the middle of this is a quarter, right? So 0, 1, 0, when the angle is 0, cosine is 1. When the angle is pi over 2, cosine pi over 2 is 0. And then the third one is the minimum. When the angle is pi, then it's -1. And then when the angle is 3 pi over 2, it goes back to 0. And when the angle is 2 pi, go back to 1. Because that's what cosines are. So maximum, intercept, minimum, intercept, maximum for cosine. So in the next video, we talk about other features. Oh no, we talk about the other terms about transformation of sine and cosine function.